Before Einstein came along, physicists already knew that objects have kinetic energy while in motion. For example, when I drop an apple from one hand into the other, it has more kinetic energy while it's falling than while it's resting in my palm. It has the most kinetic energy when it's just about to reach the other hand that's catching it, because that's when it has the highest speed. An object with twice the mass falling at the same rate would have twice the kinetic energy. Objects also have another form of energy called potential energy. This type of energy remains within an object until it is released by converting into other forms of energy such as light, heat, and motion. For instance, the apple has a certain amount of gravitational potential energy when I'm holding it in the top hand. And when it falls, it loses that amount of gravitational potential energy and converts into kinetic energy. We can describe this apple as a physical system, and the total energy content in the system remains the same from the moment that I let go of the apple to the moment that I drop it. The energy just changes forms. Another example of potential energy is the electrochemical energy stored within the batteries of a flashlight. Now, you know, flashlights don't generate power out of thin air, but instead they convert the potential energy in the batteries into electricity, which causes the light bulb to give off heat and light. Now, Einstein discovered something new and exciting by using his creativity to see fundamental physics equations in new ways. He began his investigation by starting with established expressions and equations for space, the electromagnetic energy of space, and the principle of relativity. Physicists were later able to put Einstein's theory to the test after he published the paper. They took measurements of the energy emitted by radium salts and observed an actual decrease in mass, proving the theory to be true. However, Einstein didn't come to his conclusions by running experiments. He arrived at the correct answer by deducing what follows from interpreting the units of measurement of space, time, and energy. Reasoning mathematically from established laws of physics, he found that the inertia and mass of an object diminish as a result of the emission of light. In fact, his equations showed that an object would have to lose mass in direct proportion to the amount of energy radiated. There was only one conclusion that he could make to reconcile this new information with the established laws of physics, that the mass of a body must be a measure of its total energy content. Mass and energy aren't exactly the same thing, but all objects contain a certain amount of mass energy in direct proportion to how massive they are. Albert Einstein combined logic with a fresh perspective to discover a new fundamental relationship between the units we use to measure mass and energy.